Hello everyone. Today I am excited to present my project for the concept of object oriented programming in action through the strategic pattern. This is the introduction. We have developed an interactive application where a player controlled hero can dynamically switch between different combat strategies such as punch, shoot, and spell, each with unique visual effects. Before we dive into the code, let me show you what we are working with. This is an interactive application I built where you control a hero on the screen. Let me demonstrate visually. So this is the interface and this is the hero that you are working with, and he can move in all directions whenever through your keys. Whenever you want to perform a combat strategy, just click on P. Now this is the punch strategy, and when you change it to S, this is a shoot one, and when you change it to M, this is a spell, like a magnetic one. So this is how the game does, and in the command prompt you can see what type of spells that is doing. So this is the demonstration of the project. This might look a simple game, but the architecture is direct application of four pivotal object oriented programming principles. Throughout this presentation, we'll demonstrate this project to showcase a practical mastery of encapsulation, abstraction, polymorphism, composition over inheritance. Let's start looking at the first principle, encapsulation. Encapsulation is all about binding data and methods together and hiding the internal details. The importance is clear. It reduces complexity and makes our code more robust by allowing internal implementations to change without breaking other parts of the system. Now let's look at how this is implemented in the code. Here is the core of our hero class. So these are the three files, .cs files, which I've created for the program, and this is the hero class. You can see it has a private field called attack strategy. This is the internet state and it is hidden from outside world. The hero attack method doesn't contain a single line of code about how to throw a punch or cast a spell. Instead, it simply delegates the work by calling it as attack.strategy dot execute attack. In practice, this means the hero class is blissfully unaware of the complexity behind each attack. Its role is simple: to be a hero and a command and attack. This separation is what makes the code so modular and secure. Now, the second principle is abstraction. Building on an encapsulation, we have abstraction. Abstraction means hiding complexity, implementation details, and exposing only what is necessary. It simplifies how we interact with objects and cut dependencies on specific implementations. So this is the code we have particularly used in the program. This is the code snippet, and I'll give you the explanation in the code itself. So this is the iattackstrategy.cs where we can show abstraction. This is the interface. This is the main interface of the program. The interface is a contract. It doesn't care about the specifics. It simply states that anything claiming to be an attack strategy must have an execute attack method, a name, property. It defines what must be done, but absolutely nothing about how to do it. This is this is powerful because it allows a hero class to interact with any object that fulfills this contract through a simple, consistent interface. The hero doesn't know if it's dealing with punch or a shot or a spell. It just knows it can tell the strategy to execute, and the strategy take care of the rest. This is the essence of abstraction. So these are the three spells that I have created. One is punch, shoot, and spell. Now let's go to the fourth principle, that is polymorphism. Which brings us perfectly to polymorphism is that ability of different objects to respond to the same command in different ways. It what enables flexibility and extensible code. In our code, this is the code, and I'll give you explanation in the code itself. So in our code, this is where the magic happens, exactly at this place, the player dot attack. This is just This is not just a simple line of code, but when I run the program and press different keys, you see single command produce completely different results. Whereas in the demonstration I have clicked, the arrows are helping the hero to move, and P button makes the hero to punch, M to spell, and S to shoot. So this is done through this attack dot strategy. This is where the actual performance goes. The hero knows which attack by simply clicking on the keys that I have mentioned, that have interlinked with it. So this is how the polymorphism works. This works behind the scenes. That one call is invoking the execute attack method on different objects. A punch strategy, a shoot strategy, and a spell strategy. Each object has its own implementation of the same method. This is polymorphism in action, the same interface exhibiting many forms. Now let's go to the fourth principle, that is composition over inheritance. The traditional, less flexible way to build this through inheritance, perhaps a hero based class with subclass like punching hero, shooting hero, and a magic hero, but that creates a rigid hierarchy. What if a hero needs to punch and shoot? You end up with messy multiple inheritance or duplicate code. Our approach is different. As you can see in the code, the hero the hero class doesn't inherit its behavior. Instead, its behavior through attack strategy field. This is the composition. This is the hero is composed of or owns a strategy object, and because of this, I can change the hero behavior dynamically at runtime. I can be moving around I can be moving around, switching from punch to shooting at instant and fire a shot, all without stopping the game. The composition approach is incredibly flexible and adheres to open or closed principle. Our system is open for extension, as I can add a new kickstart strategy tomorrow but closed for modification, as I won't need to change a single line of code in the existing hero class or other strategies too. So this is how the project demonstrates the core principle of OOPS by demonstrating abstraction, encapsulation, polymorphism, and composition over inheritance. Thank you.